All right, guys, so we're going to talk a little bit about the other three approximations. In class the other day, after our quiz, we figured out the formula for the left-hand approximation for area under the curve. We'll draw a little sketch here to just kind of have an idea of, I don't want a straight line. I don't know why it won't let me undo straight lines. Got a little function. Right, and we want to go from A to B using n intervals, and we figured out that this delta x is the thing we care about, and it's this is a plus delta x, this is a plus 2 delta x, and so on until we get up to b, right? And delta x was b minus a over n, where a to b is the interval we care about, and n is the number of intervals we want. And if you remember, what do we figure out? Was that if we're doing a left-hand approximation, right, we start on the left side, and we start making our rectangles, right? And then this last guy before b, right, we want n intervals. This is, the first guy is a plus 0 delta x. So this last guy is a plus n minus 1 delta x. And this is the height of the last triangle we get by plugging this into f of x. All right, so here's our left-hand approximation. That's the sum. This gives us every left-hand approximation ever. So how about right hand? Well, if we stare at this picture, what's the difference between left hand and right hand? A right hand approximation, we start at this b, right? And we go over and down, over and down, over and down, over and down, and we don't use this a, right? We don't use this a. We exclude that. So, we don't use a plus 0 delta x. And we can actually notice that b is equal to a plus n delta x, as this is a plus n, b minus a over n, which is equal to a plus b minus a, which is b, right? So these two things are equivalent. Except we're leaving off a plus 0 delta x, and we're including a plus n delta x. So actually our right-hand side approximation, we can see pretty easily right-hand approximation. The right-hand approximation. This is going to be the exact same formula. N minus 1, f of a plus. And now we don't want to include 0, but we're still plugging in 0. So this is going to be I plus 1 delta x. Oh, yeah, I plus 1 delta x. So here is our right-hand approximation, the formula for our right-hand approximation. So now what do we have left? We have midpoints and we have trapezoids. So let's do trapezoid first, because trapezoid's actually one of the easier ones. We'll do trapezoid first. Trapezoid. Okay, and I'll sketch my picture again. All right, and we're going from A to B. Right, and we still have our delta x's, but we're just gonna do a kind of a general example, we would call it. Right, so here's how we draw our trapezoids. But let's notice what's happening. If I find the area of each of these trapezoids, call this T1, T2, T3. Get a little dot, dot, dot in here. How many trapezoids do we have? We have Tn trapezoids. Right, and we'll notice that the area of trapezoid 1, this is a plus delta x. Area of trapezoid 1, area of trapezoid 1 is going to be 1/2 times delta x, right? 1/2 times the height. Then we're going to do base 1 plus base 2. That's f of a plus f of a plus delta x. Okay? And if we do area of trapezoid 2, that's 1/2 delta x, f of a plus delta x, right here, and this guy is a plus 2 delta x plus f of a plus 2 delta x. So if I do say area of trapezoid K, I guess we'll do I, area of trapezoid I, right? A general trapezoid is going to be 1/2 delta x, and just following my pattern, this is f of a plus, well, it's I minus 1 delta x plus f of a plus I delta x. All right. And you notice, like, all right, I minus 1, we did an I plus 1 in the right-hand side. There's something a little weird going on here. And what the weirdness comes from is how we labeled our trapezoids. Everything we've been labeling recently has started with 0, and I chose to label with 1 here, and that's my mistake. So I relabel this. I label this as trapezoid 0, trapezoid 1, trapezoid 2. This will be trapezoid n minus 1. So here's the formula for area of trapezoid 0, trapezoid 1, right? And you notice now, instead of the second number matching with our subscript like it used to, now it's the first number, that invisible 1 there. So if I rewrite trapezoid I with this new formula, this will actually be a plus I delta x and a plus, running a little out of room here, I plus 1 delta x. Right, and that's actually useful. What formulas have I and I plus 1 in them? Well, those are the left and right-hand side approximation. So we can actually think of our trapezoidal approximation in 2 different ways. So our trapezoidal approximation will be each of our terms has 1/2 in delta x, so we can do delta x over 2, sum I equals 0 to n minus 1. And then I missed the parentheses there. It's going to be f of a plus I delta x plus f of a plus I plus 1 delta x. So these are the 2, this is one way of writing it. But another way of writing is actually kind of cool. Since these are just two sums, and this sigma is also a sum, I could rewrite this as this: delta x over 2, sum I equals 0 to n minus 1 of f of a plus I delta x plus the sum I equals 0 to n minus 1 of f of a plus I plus 1 delta x. All right, I can rewrite them like this, right? I can rearrange sums however I want. That big sigma is just a sum. That plus sign in the middle is just a sum. So I can rewrite them this way. And furthermore, I guess this guy is being multiplied by both of them. If I now just distribute that, I could rewrite this as delta x over 2 sum I equals 0 to n minus 1, f of a plus I delta x plus delta x over 2, sum I equals 0 to n minus 1, f of a plus I plus 1 delta x. Right, so we're adding these two things together, and you realize if they're both over 2, I could rewrite this finally as delta x sum I equals 0 to n minus 1, f of a plus I delta x plus delta x sum I equals 0 to n minus 1, f of a plus I plus 1 delta x over 2. And you notice this guy, this guy, I'll just kind of box it. That's my left-hand approximation. This guy is my right-hand approximation. And we are adding them up and dividing by 2. So this is, I think this is left-hand approximation. This right-hand approximation over 2. This is the average of the left-hand approximation and the right-hand approximation. And that's just the trapezoid. It really has nothing to do with trapezoids. It's just the average of the 2. And like we said before, it's like visually trapezoids look like they would be a better approximation. And we could also see that algebraically they should be as well, because like if you have an over and an under approximation, if you take the average of the two of them, you probably get a better approximation. So if you want to remember the trapezoidal formula as this guy right here, this guy right here, or the average formula, that guy right there, or the average formula, you'll be good to go. So finally, we need the midpoint approximation. And to do the midpoint approximation, we need to calculate the midpoints, right? So we'll sketch our picture. We have to go from A, then we need to do A plus delta x, then we need to do A plus 2 delta x, and we go on. A plus 3 delta x, and we go on. All right, and remember our heights come from the midpoint of these intervals. We're going to make these rectangles by finding the midpoint and going to the endpoints. All right, find the midpoint and we go to the endpoints. Find the midpoint and go to the endpoints. And you remember, we find the endpoint by taking the average of the 2 points, right? So let's do this first one. The average of these two is going to be A plus A delta x over 2, which is equal to A plus delta x, miscopied. So this is 2A plus delta x over 2, which I can rewrite as 2A over 2 plus delta x over 2, which is equal to A plus 1/2 delta x. Okay. If I do the next one, I'm going to have A plus delta x plus A plus 2 delta x over 2, which is 2A plus 3 delta x over 2, which is 2A over 2 plus 3 delta x over 2, which is equal to, finally, A plus 3 over 2 delta x. If you do the next two, we have A plus 2 delta x plus A plus 3 delta x. So we're going to have over 2, which is 2A plus 5 delta x over 2. And if we follow the same pattern we have here, we have a plus 5 over 2 delta x. Okay? And we can keep going, we can keep going, we can keep going. But let's think about the areas here. If I call this rectangle 1 and this rectangle, again, we want to start with 0. We found that out before. Rectangle 1, rectangle 2. Area of rectangle 1, 0, area of rectangle 0. We're going to have, so the width is still delta x, and then the height is going to be f of a plus 1/2 delta x. So there's 0. Area of rectangle 1 is going to be delta x times f of a plus 3/2 delta x. Area of rectangle 2 is going to be delta x times f of a plus 5 over 2 delta x. And we go on and so forth. You notice that the tops of these fractions are just odd numbers, right? 1 over 2, 3 over 2, 5 over 2, which gives us our formula. So we're still going to have delta x out in front because that's the width for all of the rectangles. Sum I equals 0 to n minus 1 because that's still always going to be the same. And then we need to figure out what to plug in. And how do we do it? Well, there's kind of two different ways to do it. We can think of this as f of a plus. We can do it as, when I plug in 0, I have to get 1. When I plug in 1, I have to get 3. When I plug in 2, I have to get 5. That's 2I plus 1 over 2 times delta x. Okay, right? So there is one method for it. That's just exactly pattern matching. But if we were to then go about doing some algebraic simplification, just the 2I plus 1 over 2, so 2I plus 1 over 2, this is equal to 2I over 2 plus 1. That's not how I want to do it. I could just make a really easy simplification of this is I plus 1 over 2, which is then equal to I plus 1, just using parentheses, over 2. So this, again, relates it back to our original formulae for left and right-hand side. I could rewrite, I'm just going to copy and paste to save myself some writing. 2I plus 1 over 2. Can rewrite this as I plus 1 over 2. Both of them give you the same answer, but if you want to think about i's and I plus 1s, this might make your life a little easier. So I hope that was pretty good. You have some problems to do, and enjoy your Monday.